Hello and welcome to this session. In this session, let us discuss a very important topic of database management system, that is the database recovery. For the library sciences students, it may be somewhat technical in aspect, however, it is better to learn this database recovery. So, in this session, let us cover how the database crashes happen, what are the recovery mechanisms that needs to follow, and then what are the techniques that you have in the systems in order to recover the system as well as the database. Before we start, let us define the transaction. A transaction is the smallest unit of program, contains several low level tasks. So, if a simple transaction is happening like a banking transaction, wherein which you have to withdraw the money. So, there the user, depending upon the request, the amount will be deducted from the account and then will be issued to the user. So, it is a simple transaction wherein which upon the request the amount is being issued to the user as well as it is being updated in the database. So, this transaction must maintain some properties. Those properties are called as the asset properties. A stands for atomicity, C stands for consistency, I stands for isolation and D stands for durability. Atomicity is nothing but whenever the transaction happens, either or all of its operations are executed or none of them should execute. So, this is called as atomicity. Consistency, whenever the transaction happens, the database must remain in a consistent state after any transaction. There should not be any redundancy or there should not be any adverse effects. And the third thing is the isolation. In a database system where more than one transaction are being executed simultaneously and in parallel, property of isolation states that all the transactions will be carried out and execute as if it is only one transaction that is happening, and then no transaction should affect the other transaction, and there should not be any redundancy or there should not be any miss updates in the databases. And then the last property is the durability property. It states that it is enough to hold all its latest updates even if the system fails or recovers from the crash. So, the update should be required whenever a system crash happened or else whenever the system restarted. So, whenever we talk about the transaction, it should satisfy all these properties. So, let us see how the crashes happen. A computer system, like any other device, is subject to failure from a variety of causes. One may be a disk crash, the power outage, software error, fire, sabotage. There are many things wherein which with these kinds of influences a system is prone to break down. So, in any failure information may be lost. So, therefore, the DB system must take actions in advance in order to ensure that the atomicity and the isolation properties we had discussed, those should be preserved. And then for every database management system, the recovery system should be an integral part, so that there should not be any redundancies, ambiguities, and the consistent state should be existing all through. The recovery scheme must also provide high availability. Those systems should be always on. Most of the time the system should be always on. Even though a simple crash occurs, immediately it should recover from the crash. So, immediately the recover mechanisms or the algorithms or the programs to recover immediately should be happened, and within no time the database should be on or highly available. Let us classify the failures. Some failures immediately, suppose if the UPS is down, immediately we can retrieve, or else if some software error is there, it may say take some more time, wherein which you have to debug it and then you have to make it online, or you have to patch it and then you have to make it online. So, there are various failures occurring, and depending upon the failures there is a kind of classification. For some failures the information may be lost, and for some failures it may not. So, let us see the types of failures. One is the transaction failure, the other is the system crash, and the third is the disk failure. So, let us see the transaction failure. So, a transaction has to abort when it fails to execute or when it reaches a point from where it can't go any further. So, this kind of failure is called as a transaction failure. A transaction is happening, and in between, due to some reason, due to some error, maybe a logical error or maybe a system error, it aborted from the transaction. So, this kind of failure is called as transaction failure. So, the complete transaction has not been successful. So, it stopped in the midway and it is aborted from the operation. There are two types of errors which causes this transaction failure. One may be the logical error and the other may be the system error. Logical error is nothing but when a transaction is happening, it cannot complete because it has encountered some sort of bad inputs, data not found in the table that it is retrieving. Overflow error may cause because of divide by 0 and other errors, or else resource limit has been exceeded. So, these kinds of things persist to a kind of logical error, and in turn the transaction failure occurs. The system error is the other part where the database itself terminates an active transaction because the DBMS is not able to execute it or has to stop because of some system condition. Like there is a deadlock condition wherein which each and every component is waiting for some or other resource, wherein which that resource is being held by some other component. So, there occurs a kind of deadlock situation, and this kind of system error may occur. Or else suppose if the system is requesting for the resource and it is unavailable and it is long waiting for that particular resource. So, once again a system error may appear. Likewise, this particular system errors also affects the transaction, and that error is called as the transaction failure. However, whenever the system error occurs and if it is being rectified, obviously the transaction will be re-executed and will be up and will be successfully done. Then system crash, there are problems external to the system. So, system crash means the software system or else the system that you are working or else the DBMS server where the DBMS residing may had the crash. For example, an interruption in power supply may cause the system crash, or else a operating system error may cause the system crash, or else the hardware malfunction can cause the system error, system crash, or a software failure, bugs can cause the system crashes. So, whenever there is a system crash, there is a high possibility of data loss. Then the third type of failure is the disk failure. So, the DBMS is residing on the server on the hard disk, permanent storage. So, disk failures may happen whenever there is a formation of the bad sector or else unreachability to the disk, or the head itself has crashed, or any other hardware failure of the disks pertains to or else leads to the disk failure. It destroys all or else part of the disk storage wherein which the complete transaction failure will happen. Then copies of the data, there is a recovery procedure wherein which whatever the data that is residing on the disks can be maintained in the form of a copy on other hard disks also, wherein which in the later on in our discussion we can see how these particular copies can be maintained. Tapes can be like the backup on the tapes can be done, or else remote backups can be done. So, in this way we can recover from the disk failures. Then there are algorithms in order to recover the databases, and within every algorithm there exists two parts. The first part takes care of the processing to ensure that enough information exists to allow recovery from failures. So, obviously it maintains a kind of shadow wherein which whenever the database crash happens, automatically it allows the recovery from the failures. That is the first part, it takes care. The second part is whenever there is a kind of thing happened, failure happened, so how to recover? So, that pertains to the second part. So, in the second part, actions taken after a failure. First one, we are maintaining a shadow kind of thing wherein which if at all happens, how to retrieve. In the second part, what we are thinking is if at all the failure has happened, in order to recover the DB contents to the existing state, the kind of algorithm or the kind of steps needs to be written. So, these two parts covers in each and every recovery algorithm. Then whenever we talk about the disks, whenever we talk about the storages, the tapes, the secondary storage devices and other things, we normally see the storage structure, whether it is the volatile storage or whether it is a non-volatile storage. Whenever a crash appears in the volatile storage, what happens? Whenever a kind of disturbance happened in the non-volatile storage, what happens? So, volatile storages are nothing but, as the name suggests, these are volatile in nature and cannot survive system crashes. Why? Because these are very small, these carries only small part of information. Suppose if you take the case of RAM, that is main memory, or else the caches that you have are the examples of the volatile storage. So, they contains very less information, and these devices are placed very close to the CPU, and normally the whole lot of information whatever that is existing in the database may not be there in the RAM or the caches. So, whenever a system crash happens, the data that is stored in the RAM or else in the cache may not survive. So, but that is the other thing is the non-volatile storage. These memories are made to survive system crashes like a hard disk. They are huge in data storage capacity but slower in accessibility. So, the examples are hard disks, magnetic tapes, flash memory, all these comes under the non-volatile storage. So, whenever a crash appears, there may be loss of data or there may not be loss of data, but the survival factor is high in the non-volatile storage. Then there comes a kind of storage called as stable storage implementations. So, these stable storage implementation can be done using RAID systems. RAID systems are nothing but they guarantee that the failure of a single disk will not result in loss of data, and these are very simplest in nature, fastest form. These are nothing but the mirror disk, whatever the disk that the DBMS is contained, the same kind of image is being maintained on another disk called as the mirror disk in the RAID systems, which keeps two copies of each block on separate disks, one on the block that we discuss about the permanent DBMS where it is residing, and the other block will be stored on the RAID system. So, many systems store archival backups of tapes of course, but the portability factors comes into picture. Whenever we talk about the tapes, taking the backup on the tapes, storing them, suppose if we want to port it to somewhere, we want to take them to somewhere. So, the portability of that particular tape may be a kind of factor which may be restricting. And the third thing is the remote backups. So, more secure systems, they will keep a copy of each block of stable storage at a remote site. So, that particular site are not existing in the original premises. However, it will be maintained as remotely as possible, very far away places, and the backup is taken on these systems. So, writing it is a part wherein which the networks also comes into picture. So, the data from this storage, the DBMS existing in our server in the premises, thus if at all the same part is to be maintained remotely, then it should be connected through a computer network. So, whenever we connect these particular remote sites for the remote backups, so we can take the remote backup, and whenever there is a system crash, automatically whatever the data that is being maintained parallelly on the remote servers or remote sites will be handling, and they will be taking care of the restaurant transactions. So, whenever we talk about the data transfer, we talk in the form of block transfer. So, block transfers happens between memory and the disk storage. Here the memory term I am using instead of RAM, the main memory. So, whenever we want to retrieve some sort of data, or whenever we want to do some sort of transactions on a particular data, it should be carried on to the RAM, and then only we can carry on the activities. So, the block should be transferred from the disk storage to the memory. So, there may be three kinds of things happening. Whenever the data block is transferring between the disk storage and the main memory, three things may be happening with respect to the transaction. One thing is successful completion of the transaction, or else a partial failure may happen, or else a total failure of the transaction may happen. So, whenever the data is being transferring, these three, one of the three things may happen. Successful transaction, it is well and okay. In the partial failure, what happens is the block has started, the data block has started from the disk storage, and during meanwhile of its transfer there is a kind of failure. And then the third category, the total failure happened. It means that haven't started but totally failed. So, the middle part is the partial failure, and the total not yet done is the total failure. So, the system must maintain two physical blocks, as I told you, some of the like in the RAID or else in the remote sites, two physical blocks will be maintained. One is mirror disk in the case of RAID technology, wherein which at the same location image is being maintained, the complete backup whatever that the physical storage is containing, the complete mirror is maintained in the mirror disks at the same location. In the other thing, second type, remotely is maintained. So, one disk will be in the premises and the other disk will be in the remote side. So, the output operation is executed as follows. First of all, whenever we want to have some sort of transaction, it may happen in the three ways, like the write the info onto the physical block, after successful completion write on to the second one. So, the first block that is there will be written, the physical block. Whenever it is successfully completed, then the second block, we are talking about two blocks, two physical blocks, the second thing starts. The output operation is completed only after the successful write on the second block. So, we can call a transaction successfully done means, first of all, first block is to be written, and after the successful completion of the first block, second block, either it may be in the same location or else it may be in the remote location. So, the second block also need to be written. If at all both the operations has happened, then only we call that operation as a successful transaction. During recovery, the system examines each pair of physical blocks. If both are same, no detectable of errors, otherwise it replaces its content of the other. So, the physical block is being written and the second block is also being written. If both, then the comparison takes place, whether the data on both the physical disks is same or not. So, if both are same and there are no detectable errors, then well and good, the transaction is successful or else the operation is successful. Otherwise, it replaces its contents with the other. The first physical block is being updated by the second one. Then recovery and atomicity. Consider a simple instance wherein which a transaction is happening. Rupees 500 from account A is to be transferred to account B, wherein which initial values of account A is 1000 rupees and then B is 2000 rupees. So, if at all a successful transaction happens, so the value in A should remain as 500 and value of B should be updated as 2500. In meanwhile, if a system crash happens during the execution, there may be three things you have to remember. One thing is that 500 has been deducted and then system crash happened. In a normal transaction, 500 is being deducted, A remains with 500 and B remains with 2000. So, there is no update of the 500 rupees in B's account. Or else if at all there is a re-execute operation going on, then what happens? Obviously, once again a kind of deduction takes place, the first 500 has gone, once again the re-execution takes place and the remaining 500 rupees in account A will be transferred to account B. Then also it is not a kind of successful transaction. Why? Because two deductions has taken place in A and only one update has been taken place in B. So, in the simple recovery mechanism you can see here two possible recovery procedures may happen. One is re-execute and the other is do not re-execute. Re-execute, the account A will be left over with 0 rupees and account B will be updated to 2500. Do not re-execute, obviously 500 rupees has gone from account A and it is not been updated in account B. So, either of the cases the database is left in the inconsistent state and thus simple recovery scheme does not work over here. So, both the methods that we had discussed, the re-execute method and the do not re-execute method has failed. So, recovering from crash, there are algorithm has not worked. So, we have to see for the higher end algorithms. So, when a DBMS recovers from a crash, it should maintain the following. It should check the states of all the transactions which are being executed. A transaction may be in the middle of some operation, the DBMS must ensure the atomicity transaction in this particular case. It should check whether the transaction can be completed now or it needs to be rolled back. No transactions would be allowed to leave the DBMS in an inconsistent state, whatever we had seen in the earlier slide, the re-execute and no execute. Then there are two recovery techniques, one is the log based recovery technique or else the other is the shadow paging. So, these are the two types of techniques which can help a DBMS in recovering as well as maintaining the atomicity of the transaction. Let us see the log based recovery, how it happens. So, in the log based recovery, maintaining the logs of each transaction and writing them onto some stable storage. Stable storage means RAID or remote sites. So, before actually modifying the database, and then shadow paging is somewhat different, where in which it maintains shadow paging where the changes are done on a volatile memory and later the actual database is updated. So, there is an intermediate part called as the volatile, a temporary part called as the volatile memory, and that is used as a temporary storage and after until and unless the actual database is obtained. Within the log based, the log is a sequence of records which maintains the records of actions performed by a transaction. It is important that the logs are written prior to the actual modification and stored on a stable storage media which is fail safe. So, there are two types of things here we can see. Working of the log based recovery, there are certain steps which needs to be followed in the log based recovery methodology. The first is the log file is kept on a stable storage media, and when a transaction enters the system like tn start, it writes a log about it. So, the transaction started, that is the log, it is been recorded. Then when the transaction modifies an item, it writes the log as follows. Tn is the transaction x v1 and then v2. So it can be read as Tn has changed the value of x from v1 to v2. So that log is been recorded, and when the transaction is finished, the log should have a commit statement like Tn comma commit. So in this way, three kinds of logs are being recorded against each and every transaction. So there are two types of log based methods can be implemented. So the first approach is deferred modification scheme and the second approach is immediate modification scheme. The deferred modification scheme is nothing but all logs are written on the stable storage and the database is updated whenever a transaction commits. So everything is being committed wholesale. After the logs are written on the stable storage, then only the transaction is committing. And in the immediate, whenever the intermediate steps are happening, immediately the log is being updated. Each and every time each log follows an actual database modification, that is the database modified immediately after every operation. There all the operations are done after the commit is given, then only the database is updated. Here for each and every operation the actual database is modified. Then recovery with the concurrent transactions. When more than one transaction is happening in parallel, the logs are interleaved. At the time of recovery, it would become very hard for the recovery system to backtrack all the logs. And then to ease this situation, most modern DBMS uses the concept called as checkpoints. The checkpoint mechanism is nothing but for each and every point it maintains a check kind of thing, or else it maintains a save point, wherein which it records all the things, and whenever a system crash happened, it rollbacks and it sees till what extent the data is being saved. So let us see here how it happens. Keeping and maintaining logs in real time and real environment may fill out all the memory space available in the system. As time passes, the log file may grow too big. So checkpoint mechanism where all the previous logs are removed from the system and stored permanently in a storage disk. So let us see a figure over here. This is a checkpoint maintained. So at each and every interval a kind of checkpoint is maintained, and then a kind of undo and redo lists are maintained. Undo list means if the recovery system sees a log but no commit or abort log found, it puts the transaction into the undo list, or else it put the list into the redo list. All transactions in the undo list are then undone because the transaction hasn't been happened, and meanwhile the system has happened. The complete undo list, whatever that is maintained, is undone. So nothing is been done, or else it is been undone till that extent. And in the redo list, whatever that is recorded in the redo list and their previous logs are removed and then once again redone before saving the logs. So with this, before concluding the session, let us recap what we had seen. We had seen how the system crashes appear, and we had seen three kinds of failures, and during our discussion we had talked about various techniques, and then for the parallel kind of concurrent activities, how the checkpoint mechanism can be implemented. Hope you had understood this particular database recovery. However, this session is a bit technical in nature for the library science students, but it is better to know about the database recovery mechanisms and other things whenever we are working with the database management system packages. So with this I conclude the session. Thank you.